Howdy campers, and welcome back to Sea Camp Connection. I'm so glad we're here back for our winter edition. This time we're going to be talking about how animals survive in their environments, specifically when those environments are cold. So we're going to be touring the deep sea, the Antarctic, and the Arctic waters of our oceans. But first, before we get started into all of those awesome topics, let's first take a tour of the ocean and talk about our layers of our ocean. Our first layer of the ocean is the Epipelagic Zone. This is our light zone of the ocean, our Epipelagic Zone. And our Epipelagic Zone is to about 200 meters deep. Now, this zone is where you're going to find a couple of really cool species. First off is going to be our species that use photosynthesis to make their own food. So algae, phytoplankton, corals, those things that make their own food through photosynthesis are going to need to be as close to the light as possible. So like our ceraceum, our phytoplankton, our ceraceum is able to live at that surface of the water and be able to produce its own food through photosynthesis. We also have corals, and corals will have algae inside of their tissue, and that algae is able to produce food also by photosynthesis, helping the coral out for feeding purposes. So that's the types of animals that you're going to find at the surface. Also, we have our most abundant species, our most abundant animals in the ocean, which is going to be our plankton. So this is our zooplankton. We have our plant-like plankton, which is our phytoplankton, and our animal-like plankton, which is our zooplankton. So this is a copepod, like that little green guy on SpongeBob, and they also live on the surface of the water. Those are our basis of the food chain, our planktonic species. We also have our coral reefs in things like anemones. So we have our anemones that live in the coral reefs, and of course we have to have our clownfish that also live in our coral reef. So our tropical fishes, our plankton, those types of animals will be found here in this epipelagic zone, the first 200 meters of the ocean. As we get a little bit farther down into the ocean, we get into the twilight zone. The twilight zone is the mesopelagic zone, and that's about 1,000 meters deep, okay? And whenever we have our epipelagic zone and our mesopelagic zone, we have a lot of familiar species that we know a lot about, like our sea turtles. Sea turtles will swim into the mesopelagic zone just a little bit to be able to catch their food, their prey. The leatherback sea turtle dives the longest to be able to catch those big lion's mane jellyfish. So those are deep diving species. That's why it has that leatherback, that cartilaginous carapace, their shell, that will be able to kind of collapse and expand and be a little bit more malleable, a little bit more movable and bendable, so they're not crushed with that pressure. So we do have sea turtles. The green sea turtle, which is this one, will want to stay a little bit further to the surface because they're eating algae, and so they want to stay there. But in our mesopelagic zone, we also get larger predators like this blue shark here, and the blue shark will be able to dive down and hang out and find larger fish species like tuna and mackerel and things like that. Now, as we go into our next zone of the ocean, we're starting to see a little bit more loss of light, a little bit difference in those animals that we're used to seeing, some of our deep sea animals, and it doesn't look like it's that far, but as you're diving down, you're losing some of that light, and you're losing the ability for those animals to be able to see in the light. And the next is the bathypelagic zone. So our bathypelagic zone is our midnight zone of the ocean. That's its common name, and it's all the way down to about 4,000 meters, okay? 4,000 meters. And in this zone, you're going to start to see animals, like I said, that have adaptations to live without light. This is the frill shark. The frill shark, it's not very common to see by us. Only a few have been recorded, and every time they have been recorded, it's because they're ill or injured and they're not able to survive anymore. Usually they have problems with their buoyancy and they're floating up to the surface so they can basically in their life. So we don't get to see a lot of documentation of these animals. They have really large gills that allow them to absorb as much oxygen as they can out of the water, and they have these large eyes, and those large eyes allow them to trap as much light as they possibly can. To put this in perspective, the Titanic, all right, you guys might be familiar with the Titanic. This is that famous ship that was sunk. Lies around right here in the water column. So it's in our Epipelagic Zone. And in our Epipelagic Zone, the Titanic has barely been explored. There's been a couple of documentations. There's been a couple of ROVs, remote operated vehicles, that have gotten to go and explore the Titanic. But it's been really cool. They've seen a lot of really cool deep sea corals that have started to settle there. And it's this kind of uncharted, unexplored environment. So just to put that in perspective, the frill shark in the Titanic are really far down in the ocean. We also have one of our deepest diving marine mammals, which is the sperm whale. So the sperm whale is that deepest deep diving marine mammal. The sperm whale will use echolocation because they can't see that deep in the ocean. There's no light. So they're able to use echolocation to find their prey, which everyone famously knows their prey, which is the giant squid. So our giant squid will reside in that layer as well. And so those sperm whales will dive really far depths to be able to do that. And there are a couple diving adaptations for marine mammals to be able to do that. One is called apnea. They can reduce their heart rate. It's also really cold, so they basically kind of dive down kind of almost motionlessly to conserve as much energy as they can. They can hold their breath for a very long time. They slow down their heart rate. It's really cool for them to be able to do that using echolocation to use their ability to make echoes of sound back to their brain so they can try to emit a picture. So finding those squid can't be easy, and they are highly skilled at that. So our next zone of the ocean is our Epipelagic Zone. Our Epipelagic Zone is called the Abyss. Pretty easy. And in the Epipelagic Zone, it goes to about 6,000 meters. And this is where our famous anglerfish will reside. So they are the ones that use bioluminescence to be able to trick and attract their prey with this bioluminescing angler at the top. So that ability to produce light from life. Bio means life. Luminescence or lumen means light. So bioluminescent, light, life. So they attract a bacteria that is bioluminescing onto that angler, and they can emit light in that angler and attract fish. Those fish will come towards it, and then nom nom, it'll eat it. So our last one is our Hadopelagic Zone. This is the trenches. So this is whenever we're talking about our trenches in the bottom of the sea, and there's a couple of them. And one of the most famous one is our Marianas Trench. So the Marianas Trench is the deepest part of the ocean, and our Marianas Trench has barely been explored, which is crazy. And we call the bottom layer of the ocean the benthos. The benthos. So on the benthos, that's where we have a lot of our really cool deep sea corals. This is where all that marine snow is going to go, so all the dead and decaying material from the top will go all the way down to marine snow. So you get a lot of things like worms. These are red tube worms, and the red tube worms will eat that dead and decaying plant material as well. And they're going to be found all in the benthic layer of the ocean, all the way down into the Marianas Trench. Now, the deep sea has, like I said, has barely been explored. They have what's called ROVs, remote operated vehicles, that are void of people. They're just remote control, kind of like toy cars. So if you're into robotics or anything like that, that's super cool. We use those to be able to explore coral reefs, and so you can keep divers safe and people safe, and just be able to get pictures and images. So there's been a couple of explorations, and there have been some explorations with people on them. I've gotten a really cool opportunity to speak with a scientist who was on an expedition down to the deep sea, not quite the Marianas Trench, but down to I think she was more in the Epipelagic Zone. And whenever she was describing the journey down to the deep sea, it was really cool to hear her talk about how at the surface of the water, she was just in a tank top and shorts and just hanging out. It was hot, it's like in the middle of the summer, and she's at the surface of the water on the ocean, the sun's beating down on her. As she is descending from the surface of the water all the way down, she was constantly putting more and more layers of clothes on. So as she's descending, it's getting colder and colder. These animals have to deal with a lot of coldness because they're so far away from the sun. So as she's going, she's putting on jackets and socks and extra layers and hoodies and things like that. And as they're ascending, after they capture their picture, as they're ascending, she's taking it all off because it's getting warmer and warmer. So a lot of the different animals that are living at the bottom, fish have antifreeze proteins in their blood that reduce them from freezing. There's a lot of different cool adaptations that animals have to deal with these cold environments, which is super awesome. So as you get further, you have our closer to the surface, we have our less hardy species, and then we get some really cool animals that live at the bottom. And the deep sea hasn't been explored very much. There's still a lot to learn and a lot of knowledge to gain. We actually know more about the surface of the moon than we know about the deep sea. So there's a lot to be able to learn and information to be gained. Now, one more thing that I want to talk about that I think is really cool, that kind of blows my mind a little bit, is color loss in the ocean. So the sun is producing light, and with that light it's producing colors. And there's 7 main colors that it's producing. There's an acronym that we say ROY-G-BIV, ROY-G-BIV. So red, orange, yellow, green, blue, indigo, and violet. Those are our 7 main colors, right? And those colors basically we're able to see them. They're reflecting off of a object into our eye, and we're able to see that color, right? So as you're a scuba diver, you lose some of that color because water absorbs light. Let me give you an example. So this is my, I'll do both. These are my dive fins. I'm a scuba diver, and I, no shame, have hot pink dive fins. Whenever I'm at the surface of the water snorkeling or taking out to a dive, my fins are hot pink. That's where my dive buddy can see me. But as I descend into the water, and as I go deeper down into the water, my fins start to lose this red reflection of light coming to my eye from the pigment, and they turn completely blue. So the water absorbs all of that color from the red. You lose color, all right, as you're losing those wavelengths, as they're being absorbed by the water, you lose the ability to have that reflection of light back into your eye to be able to see that. So you lose them on that ROY-G-BIV scale. So red, orange, yellow, green, blue, indigo, and violet. That's why as a scuba diver, whenever I'm at depths of 60 to 100 feet, my fins look completely blue. It's really hard to understand if I'm not explaining it very well, but one way that I really kind of clicks to me is if I'm yelling from outside the sea camp dorms, "Hi campers!" If you're right next to me, you're gonna hear that really well. You're gonna be like, "Rita, why are you so loud?" But if you're over at the pool like across the other dorm, all the way over at the pool, you're not gonna hear me very well, if at all. As you're going farther and farther, you're not gonna be able to hear that. Sound travels in waves as well. And as you're farther away, you're getting weaker. That light is being absorbed by the water, and it's getting weaker. And so you're not able to take in those colors. So it's a really cool concept. A lot of animals that live in the deep sea have beautiful colors, like our red tube worms, our squid, shrimp species that are completely red. And they have, so like why things have different colors is, they're venomous or they are eating something that's changing their color. And that doesn't change even in the deep sea. But what does change is the ability to absorb that light. So they don't really appear to have any color whenever they're at the bottom of this deep sea. And whenever those scientists will turn on their big, big lights, you're able to actually see those colors because you have these white lights that are going and they're having different wavelengths that are being able to show those colors. So it's really cool. I think it's awesome. It's kind of like I have mood fins. I'm unhappy at the surface of the water, but I'm really happy whenever I'm scuba diving. So that's how I like to think about it. It's really awesome. And the ocean is a wonderful place, and I'm so excited to explore it with you from the surface all the way to the deep sea this week at Sea Camp Connection. So I'll see you on the next video, and I'll see you at our Zoom meeting.